just so you guys know, I really, really, really appreciate that you're here. Some people apparently maybe either are starting their spring break early, or they don't like the rain, or a combination of both, or whatever. What I want you to do is you obviously brought your kids because I asked you to. Yes? Yes. All right. Who did not bring theirs? Anybody? How many people? Everybody else has theirs? Just you guys? Okay. Did you? Yeah, you got yours. Okay. All right. Let me go get what I want everybody to do. Hey, Natalie, did you bring your kit?
Yes.
Nice. What I want everybody to do right now is create a triangle, a right triangle. Make it funky. Make it a right triangle, but go crazy with it. Just, you can make it tiny, you can make it big, you can make it skinny, you can make it tall, you can make it fat, you can make it whatever. Just make sure it's a right angle. Did anyone's kit come with more than one of these pegboards? Few of them had more than one for some reason. You need one, and then I'll be right back.
What do you want?
All right, let's see. Oh yeah, that's right. You can use the phone next to you. You're good. You're good. Man, I tell you what. If I was smart, my job would be so much easier. All right. So what I want you to do now is, if you have your protractor, there should be a kind of a ruler at the bottom of your protractor. Yes. If you don't have your protractor, or if you have one that doesn't have a ruler, I have rulers. So you can come up and grab a ruler. I'm gonna make my triangle. Don't go crazy, Jeff. There. Woo! All right, let's see if anybody's pops. Did you bring your stuff? Yes. So make it right triangle. Any size, any shape, but make it a right triangle. Ruler? Yes. Anybody else? So what do you guys think I'm going to ask you to do? You know, we have no idea, man. We never have a clue. What could I ask you to do, considering what I've had you construct and what I made sure you have access to? Can't find an angle with a ruler. You could with a protractor, but I just want us to use the ruler part, yeah? But that's a good point. You could have students use their protractor, get the angles, and they could see it's 180 degrees, correct? So let's kind of talk beyond what I had in mind. Then you can have them create a different triangle that's not a right triangle. Then they could do the protractor again, it comes out to be 180 degrees. You guys see what I'm saying? And no matter how they arrange their triangle, 180. So it's a beautiful concrete, not proof, but experimentation with getting what the angles have to add up to. Anybody else have a clue as to what I'm about to have you guys do? Verify Old Greek to you. Yes? Old Greek cult leader. So do it. Verify the Pythagorean. Let's see what you guys do. I want you to verify that the Pythagorean theorem holds for the triangle you created. You could use centimeters, you could use inches, as long as you're consistent. Unfortunately, the pegboards, I was hoping they were like an inch apart, but they're not. So that's why I want you to use a ruler. Oh, you need... Oh yeah, that's right. We can do that. I guess I can. Try. Ba-ba-da. We can work it out. It's not too bad. All right, let me see. So to verify the Pythagorean theorem, I'm going to put on my glasses. So let's see. Yeah, sure, I'll use centimeters. Why not? So I get my base. No, oh, real quick. I almost forgot. Let me ask you guys something important here. Let's look at the inches side, because I'm almost certain most of us are going to use inches, and I don't blame you. Okay. God. All right, give me a second. Let me just turn these out. Oh yeah, that's what's wrong. That's better. Maybe this can be back on. Let's see. Okay, wait. Do you guys, if you're using the inch side, yes? Do you see how, what is that obvious to this guy? Yeah, that would be 1.5 inches, yeah? What would that be? A quarter, because it's half of a half, yes. That'd be 1.25. What is that one? Yeah, the same way you got a quarter, you get this as an eighth. It's a half of a quarter is an eighth. So what's that one? What's half of an eighth? 16. And if you want to double check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that broke it up into 16 parts. They're all equal, so that's 1/16, yes? So you could be not very, but you could be decently precise in your measurements. Does it make sense that I don't want to round to whole numbers? Will Pythagorean theorem work if I round that much? Do you understand that it might not? Because I'm not giving it the real measurements, yes? Okay, so I'll go ahead and use inches because I feel like most of us probably used inches. Where's my glass? Okay. Hey! So I'm gonna measure mine. I got, ooh, look at that, it's almost 4. So it's like 4 and, I'd say 4 1/8 roughly. So I'm gonna kind of keep track of my measurements. So this is 4 1/8. My picture doesn't have to be nice because I have my triangle here. This one comes out to be, that is about 3, 1, 2, 3, 4. Yeah, that's about 3 1/4. Okay, and then this comes out on mine to be, bless you, 5, I'd say 5 I'd say 5 1/8, about Probably a little bigger than that, but we'll see. So I could make this, if I wanted to, 3.25. This will be 5.125, and this will be 4.125. So how do I, is everybody with me? Are you guys playing along? Okay. The more you round, the less accurate this is going to be. And I already kind of said that I think my hypotenuse is a little bit bigger. Anyway, how do I verify the Pythagorean theorem? What triangle is this close to? What right triangle that we know the sides for is this close to? 3, 4. Okay. I'm pretty sure this has come up. There are some right triangles whose sides are whole numbers. Most right triangles will have at least one side that's not a whole number because I have to square them and then square root them, yes? 3, 4, 5 is one of the triangles that has nice whole numbers for the sides. 5, 12, 13, 7, 24, 25. There's a lot of these, and they're called either Pythagorean triplets, or if I remember correctly, Euler triplets. But we'll just go. All right. How do I verify the Pythagorean theorem? What do I do? What's the Pythagorean theorem say?
A squared plus b squared.
Yeah. So what's the only side that I really have to be careful about? Which side is C?
The side opposite the right angle.
Yeah! The biggest mouth, yes? Biggest stick in the mouth. So I'm gonna check and see this 3.25 squared plus 4.125 squared. Does that equal 5.125 squared? And I'm almost certain it's not gonna be perfect because I couldn't be very precise with my measurements, yes? But let's see how close I got. And you guys do it for your triangle. Hopefully you guys created all kinds of different sides, triangles. So if I do that, and that. So this is the a squared plus b squared, and this is the c squared. Are they the same? Are they the same? Are they the same? No. Are they close enough? Are they close enough? Yes. If you do a squared plus b squared and you get 20, and your c squared is 30, that's bad. Why wasn't mine perfect? Do you guys remember when I measured that hypotenuse, I said something. I said it looked a little bigger than this. If this was a little bit bigger, wouldn't this be a little bigger?
Yeah.
Wouldn't they maybe be the same then? Okay, so when you make your measurements, we're all just human. I'm sorry. You want to play along? Make a little triangle. Wait, you gotta make a triangle with. And then measure the sides. How are you guys doing? Can anybody else share with me the dimensions of your triangle? Anybody want to do that? Yes?
2.5 squared.
Wait, sorry. So you got 2.5
Plus 3.25 squared, and it equals 4.1.
So this one you measured to be 4.1.
4.1.
Ooh, look at that. I mean, did you measure it to be 4.1? Okay. Excuse me. And you used inches.
Yeah.
The 0.1's neat, but okay. So then when you squared these, how close did you get?
I got it like on my
2.5 squared plus 3.25 squared is 16.8125. And if I do 4.1 squared, yeah, that's really damn good. Shit. Showed me. Okay. How are you guys doing? Did anybody else want to share what you got? What kind of triangle? Anybody make a big ass triangle? Anybody make a bigger triangle? What were your dimensions, Adrian?
We got 3.25
3.25,
and then 5.5
5.5,
And the other one was 6 3/8.
6 3/8. What is that, Jeff? You can do it. Yeah, thank you. So let's see. 3.25 squared plus 5.5 squared, and then compare that to 6.375 squared. Damn good. Yes? Especially with freaking rubber bands and a piece of plastic with tick marks on it. Yes.
So mine's 3 off, like 3 whole numbers.
Ooh. Intriguing. And it's over here just violating the laws of geometry. Which one is yours? Oh, the big one. What'd you get? Sounds about right. Oh, I see, okay. Oh, yeah, yeah. The bigger the triangle, the bigger the propagation of error. So yeah, that's fine. There's an idea called relative error. So if my triangle had a measurement of 3 and I was off by 3, that's 100% off. Yes. Yours has a measurement of like 8 and you're off by 3 or whatever. So the relative error is smaller. Does it make any sense? So that's fine. Okay. Does it make sense if I measure one side and square it, add it to the other side, square it, and both measurements are a little off? When I square and add them, that's really gonna be even more off. So you're fine. If you had a small triangle and you're off by 3, I was gonna be more worried. Okay. Are you guys understanding what's happening? Can you guys all take your board and please take your thing off of there. Be careful, don't let it snap off and go flying into somebody's eyeball. Can everybody please create a trapezoid? Not a trapezoid, sorry. Yes, a trapezoid. So the way you can do that is make a triangle and then do like this. If you want to. Don't make yours like mine. Make a different trapezoid. You can make a more traditional trapezoid. Like that. Ooh. Make it a little less traditional. There you go. Ha 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 ha. Oh, I'm sorry. An extra one of these? Yeah. I thought. Wait. Oh yeah, I gave mine away. Can you? No, you're good. Can you sit next to Adrian and make yours? Adrian, can you? Huh?
Yeah.
Adrian. I was gonna have to bring the power of the teacher. Yes, you will. Now, we don't have a theorem for side lengths of trapezoids. So what do you think I could show with the trapezoid I've created? Sure, but okay. I could make two right triangles, but it doesn't really come to the idea of the sides of every trapezoid. I don't have like a Pythagorean theorem like me. I do have a formula for area. How could you estimate the area of that trapezoid? And there's like Homer problems that are like this. How many whole squares? So now I'm going to use my peg marks as my units. Yes. So let me ask you this: how many units long is what's the bottom base for mine? One, 2, 3, 4, 5, 6. Yes. Can you guys do that for the one you did? Draw a little trapezoid on a piece of paper so you can keep track of your measurements. So mine was 6 across. Mine is 1, 2 tall. and my top base is 1, 2, 3. Yeah. Now, can somebody, looking at mine, if I want to estimate the area of my trapezoid, you guys see how it has one square unit thing here? I'll call it a square peg. Is that cool or whatever? I don't care. So 1, 2, 3, 4, 5, 6 full squares. Do you all agree? Now my trapezoid, this is kind of nice. You see how that kind of fills this in? So that's 1, 2, 3, 4, 5, 6, 7. And then, do you see how these definitely make more than 1? Do you guys agree? So I'm going to call that 1.5. So I'm going to say that's 8.5. So that's an estimate, yes? Can you guys all do that for your trapezoids? Does everybody understand what's happening? And again, we're just poor little humans looking at a freaking rubber band. So it's not going to be perfect, but it's going to get pretty close. Especially if you're careful. What did I just say? 6, 7, 8.5, yeah. Okay. I feel pretty good about that. So my guesstimate for my area is 8.5 square units. Just for the people at home. 1, 2, 3, 4, 5, 6. Did I leave one out? Damn you, Jeff. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. Okay. So let me show you. It's really funny being a teacher when you're too close to what you're trying to do. You leave one out. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. Okay, so that's fine. 9.5. So you guys all have your area estimates? Just counting the number of full blocks and partial blocks? Okay. It's not going to be anywhere near perfect. We're all good. I predict that some of you guys will have better than me. And I'm cool with that. What's the area of a trapezoid? What's the formula for the area of a trapezoid? Same as a triangle, except it's got 2 bases, right? So in general, what's the area of a trapezoid? What's the area of a triangle? 1/2 base times height. This has 2 bases. I want both of them in there, so what's the area of a trapezoid? Yeah, 1/2 base, 1 plus base, 2 times height. Do you see how that's basically triangle area? But I have both of my bases in there. And of course, last time we proved this to be true. So let's see how close I got. I feel like I'm probably, let's see. So I got 1/2, my bases add to 9, and my height was 2. So I got 9. That's pretty damn close. I'm very happy. I'm very happy. What's yours? Is everybody playing along? Did your estimate actually be close to the real number? Does anyone need help? You've taken me before, you took me last semester. This seems like something I might have set up here that during a test you have to come up and do it. You might want to make sure you can do it. Just a friendly suggestion. You guys doing okay? Sort of? What's up? So what did you get for the estimate? 11.5. Let's see, watch. 3, 9 in here, right? 9 full ones. This and this make a full one. You see that? This and this make a full one. That's 10, 11. These two make more than full ones, so that estimate 1.5, so that's 12. So you got close. Okay. And then if you do, now if you do the formula, some of the basis is 10, yes? So 1/2 10 times 2 is a triangle. Well, wait a minute, let me make sure. 1, 2, 3, 4, 5, that should be 5. I think you counted the first 10, but you see I've got room to get 1, 2, 3. Yeah, so I think all of these are 1, 2, 3. Yeah, 1, 2, 3, 1, 2, 3, they're all 1, 2, Is everybody doing okay? Do you guys really understand what I just said? This could very well be a problem on the test. Okay. So I want to keep your pegboards out. I want to finish, we basically got area formulas for just about every shape that we have to worry about for this class, except for two. Well, really one, but it's related to another one. And this is something I teased last time. What's kind of like the weirdest shape that you really don't use much? This is a weird question, but a shape that we've looked at, it's a quadrilateral, that you really don't ever do much with. Kite, right? You all agree kite's kind of a weird little dude? Mostly because we just don't do much with them. You guys all know parallelograms much better than you know kites. Yes? What shape is directly related to a kite? Like if you took a kite and did something to it, it would become this other shape easily. Rhombus. So a kite, you normally think of it as having a long chin, because we think kite, and we've seen kites, and they normally have a long chin. Does that make sense? If I just push that chin up, I can make it into a rhombus. The chin doesn't have to, the chin can be small, it can be long, or it can be the same size as the hat. And then it's a rhombus. Is that okay? So it seems like, if I can get the area formula for a kite, it should actually apply to a rhombus, because a rhombus is a kite. Do we already have a formula for the rhombus, though? We do. Because what else is a rhombus? It's a specific form of... No, a square is a specific form of a rhombus. A rhombus is a specific form of a parallelogram. So if you take a parallelogram and you smoosh it until these sides are the same as these sides, that's a rhombus, yes? Everything I just said, the more sense it makes, the more you understand it. So a rhombus is a special type of parallelogram. A square is a special type of rhombus. It's kind of like what shape can I start with, and then I do something to it and make it this other shape. That's sort of the idea. I put more restrictions on it and it becomes this other shape. So what's the area of a parallelogram? Based on site. So what's the area of a, oh shit and a half. What's the area of a rhombus? This gets kind of interesting, because what is it about a rhombus? What's true about all the sides? They're the same. So what's the area of a rhombus? S squared. Yes? Isn't it based on site? I'm sorry, not S squared. Get out of there, Jeff. The height would be H, so it would be SH. Shh. Don't tell anybody I made a mistake. Now, there is a different formula for rhombus that it inherits from kites. And this is kind of nifty. Can everybody draw like a standard kite, like a little hat dude and then a long ass chin dude, yes? And there was a very kind of on the side property of kites relating to their diagonals. If you've drawn your kite, can you draw in the diagonals? Now, even from our admittedly, for me that's pretty good, admittedly shaky kite drawing, right? And I'm speaking for myself. You might have had a fantastically beautiful one, especially because I never forget, I never remember. I have a ruler. Actually, I'll be right. Does anyone remember, or what does it make sense happens with the diagonals? What do they do, the diagonals? What do they do with each other? They do something specific. They intersect how? Based on that picture and based on your picture, what would you guess they intersect at? At a specific angle, yes? What does it look like that angle might be, how they intersect? 90 degree angle, good. makes sense because the kite is symmetric on both sides. There's no way they meet at a different angle because that would say that one side is leaning away or something. They're perfectly symmetric to each other. So on one level, it makes complete sense that they actually meet at a 90-degree angle. Okay. So let me call this here, I'm going to call this A, and this whole thing here, I'm going to call it B. Is that cool? We currently do not have the formula for the area of a kite. Do you all agree? A kite does not fall into anybody else's definitions at all. It's its own little thing on the side. I can start with a kite, swoosh its chin up into its head, and it becomes a rhombus. Sounds painful. So we're about to develop the formula for the area of a kite. And you're all like, finally, my entire life, I've been waiting, been asking people, hey. It's pretty cool. That's this diagonal's length, and that's this diagonal's length. A, B. Yes? Do you guys see the two main triangles that this kind of breaks up into? Two isosceles triangles. They just happen to be this top one here and this bottom one here. Yes? So if I take this top one and this bottom one separately, that's also A. Is that cool? Because that's the same line. I just kind of chopped it right there. You guys with me? Is everybody with me? Where has B gone? Is B in either one of those triangles? Okay, so here comes a little bit of algebra. However tall this is, and however tall that is, what do I get when I add them together? Frequently B. Yes? I don't have a clue how tall either one of them are, do I? So, this little one up here, just because he's up there first. How tall do you want to call him? It can't be B, because we just said B's not in either one of them. So give me some other letter. How tall is he? L, sure. How tall is this one then? Don't tell me some other letter. You shouldn't have to use any other letter. Let's see if anybody gets this. If that little triangle, if this was 10, and this is 2, how tall is this guy? Yeah, if the total height was 10, and this is 2, this is 8. If the total height is 20, and this is 4, 16. So the total height is B, and this is L, B minus L. It's the whole thing minus how much that little greedy triangle took. It's not greedy, he's got a little bit, poor little dude. So how tall is this one again? Ah! Okay. So we are deriving the formula for the area of a kite. At the most, I would ask you to do this as a bonus question. You're never going to have to do this yourself. We're creating the formula for the area of a kite. I always want to check in with you guys because I know as a student you're like, am I supposed to do that? No. What is the area of this triangle? I'm going to call this triangle 1. I'm going to call this triangle 3. Jeff, shut up. So what's the area of triangle 1? You can do it. We know everything we need, yes? What's the area for triangle 1? Good. 1/2 AL. Is that cool? Call me Al. What about area for triangle 2? Don't overthink it. It looks difficult, but it's the same idea, right? Good. So how do I get the area of my original kite, dude? You can do this. How do I get the area of the original kite? Take those areas and add them together. I love it. Do it. I love I'll give you a little clue. Distribute. Try to add those two areas together. You're all the way. Algebra this early on a Wednesday before spring break. Yes. Right? What do I get when I distribute?
1/2 AB minus AL.
Almost?
1/2.
Yes.
1/2.
What do these do? Cancel. So the formula for the area, let me call this AK for kite, is 1/2 AB. How do I just say that? What were A and B? What were A and B for my kite? They were the
The height.
better than that. The connected opposite corners. What do you call that? Starts with a D. Diagonals. So if I know the diagonals of a kite, I just take 1/2 their product. That is the formula for the area of a kite. So that is also the formula for the area of a rhombus. If I know how long the diagonals of a rhombus is, I just take half their product. Is that cool? If I want to, because I also have base times height for a rhombus. Okay. All right. So I'm going to do two things now. I think I'm going to show you some videos first, and then we're going to do a few problems from a little handout. We're not going to do all of them because there are a lot. So I'm going to tell you which ones to do. And then we're going to leave a little early. Is that okay? Even if it wasn't, it's going to happen. Okay. So let me turn this off so I don't get copyright strike looking at this. And before I do that, real quick, I meant to do this earlier, but I'm going to do this semi-quickly. So this is a kite. This is 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6, right? The diagonals. Half 4 times 6 is 12. And then if I do, let's see if you guys are with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and almost 12. So I almost get 12 if I just try to estimate the area. So sure enough, the 1/2 A times B is close to what I get if I try to estimate the area. You guys kind of with me? And again, kites are weird because we don't work with them very often. This kind of problem, real quick, on number 2. Remember these little blocks? What do we call these little blocks? Little blocks, Jeff? No, what do we call these? Anybody remember? There were the longs and the flats and the absolute units. Yes? Okay. So this is a 1/9. And I can rearrange it to be a 3/3, yes? So this is a really good way for students to kind of like do a problem like this, is to have the manipulative, so they have something kinesthetic, they can work with it. Oh, did I turn you on? No. Oh yeah, I did, look at that. So here you're gonna graph this out, and hopefully you guys made the 3/3. And then you get, oh my God, Jeff. Get your glasses. So this will be 3/3. Oops, 3/3. So real quick, what's another way to say this without any geometry? How could I ask this question non-geometrically? Why is the answer 3 and 3? Because they also make 9. So if I said, okay, 1 times 9 is 9, give me 2 other numbers that multiply to be the same thing. 3 and 3. So this could be a completely numerical problem. It could have no connection to geometry. Area is beautiful for mimicking multiplication because the area of a basic rectangle is length times width. I don't know if you guys are with me or not, so. Okay, and of course, let me push it a little bit. This goes into factoring. When you have to find 2 numbers that multiply to something and add into something else. That's a number problem, but you can actually make it geometrical. Okay. Number 4, 2 by 6. So there's actually a few different answers. Would you take, if you were the teacher, would you take a 6 by 2 as an answer? Yeah, 6 by 2. Sort of a cheap way to do it, because then they could just do a 9 by 1 or 9 by 1 for this one. You see what I mean? But what'd you guys get? What's the other obvious one? Maybe not so obvious, I don't know. Yep, 3 and 4, 4 and 3, yes. So you can either have a 4 by 3 or a 3 by 4. I decided to do, that's interesting. Why did they say 2 by 6? It should be, all right, well, using their own convention here, this would be a 3 by 4. Okay. So those aren't that terrible. The way to analyze worksheets like this, though, are, imagine you gave this to your students. How would you handle questions? Oh, I don't know if that helps. Number 2. Now this is the opposite kind of question, yes? I want the same perimeter but a different area. So what do you have to do? All right, well, the area of this is 6, but what do you really have to do? You have to find this guy's perimeter. What is this guy's perimeter? What's that guy's perimeter? 14. 1 plus 6 plus 1 plus 6. So I need a rectangle that also has a perimeter of 14. How did you guys put together, anybody want to share with me, how did you put together a rectangle with a perimeter of 14? Yes?
I realized that the 2 sides would end up being 7 to get 14.
Good, beautiful. So 1 plus 6 is 7 and you double. So all I need then are 2 numbers that add to be 7. So the first problem was I just need 2 numbers that multiply to be 9. And then the other one was multiply to be 12. This one is I need 2 numbers that add to be 7. So then you can have all kinds of rectangles fit the bill. So what was your rectangle?
2 by 5.
Anybody else have a different one?
3 by 4.
3 by 4. Yeah. So acceptable answers for 2 is 3 by 4, 2 by 5, as long as they add up to 7. Is that cool? Because if I go halfway around the rectangle, I'm going to get half the perimeter. Okay. Number 4, same idea. I need two numbers that add to be 13. So anything that adds to be 13. So what'd you guys get? Anybody? 7 and 3.
10 and 3.
Oh yeah, 10 and 3. 10 and 3 is better. Add to be 13. And then anything that has to be 13. 4, 9, so forth. Okay. I like it. So if you get really high up in math, not really high up, but really high up in math, there are certain problems, there are certain problems that are easier to do algebraically and certain problems that are easier to do geometrically. So this is kind of like the first baby step into that. So if I had to kind of just work purely geometrically, this would actually be semi-difficult. But if I'm allowed to bring in my just numbers, just looking at this analytically, numerically, then it's not so bad. This is nice. What's the perimeter of this one? Yeah, 4 times 9, you got 4 sides of 39. Squares are awesome. Thank you, squares, for existing. They didn't give any units, which is bad. But, you know, what about 12? How do I find this guy? What do we call that? We don't call it the perimeter, of course, we call it the circumference. And what's the circumference? 2 pi r. So that'll be 14 pi. And if you throw that in your calculator, do you guys, on your calculator, do you know where your pi button is? Now, this sheet says use 3.14. Now, of course, that could be because the calculators students use at this level might be the very, very basic ones that don't even have a pi button on them, yes? But if you have a pi button, you can see how wrong it is if you use 3.14. So if you use pi, it would be 43.982 roughly. And if I use 3.14, what do you guys get for that? Anybody do it? Yep, 43.96. Not too far off, yeah? Do you guys understand? 3.14 is not pi. Although if you write it and then do a mirror image, it looks like the word pi, which is neat. You guys have heard of that, right? 3.14, if you mirror image it, especially if you make your 4 like this, it looks like pi. No?
Yeah.
Yes? Okay. Evidence that, you know, there's aliens out there doing everything. And of course, this guy's not too bad. How do I find this guy's perimeter? There's a really nice way to do it. Somebody brought it up earlier. Just add these together and then double it. Yeah. 7 plus 10 is 17. Half plus half is 1, so that's 18. If I double 18, I get 36. Okay. This one's kind of nice, yes? Don't kick the baby. So we have the diameter. What's the other way to formulate circumference formula? Instead of 2 pi r? What's the other way to do it, not 2 pi r? Pi times d, yes? So this would be 11, get out of there, 11 pi. And again, let's just go ahead and use 3.14 because that's what they told us to do. And I get 34.54. Let me make sure, find the perimeter. Okay. 18. This one's nifty. I saw at least one group I saw working on this one and I figured out what they had to do. I can't get the perimeter because they didn't give me the freaking other side length, correct? But how do I get the other side length? Pythagorean theorem, yes. So the one side I don't know, what's the only letter I can't use if I want to use the Pythagorean theorem exactly how it's stated? I don't know if you guys understand. The bottom I don't understand. I don't know what that length is. What's the only letter I can't use to define it? C. Which one is C? 10. This has got to be C. And then I don't give a shit which one of these is A or B. I'm just going to call this A. So A squared plus 6 squared equals 10 squared, yes? There's a shortcut here, but I'm going to do this first. 100 minus 36, 64, and hopefully you guys know what times itself is 64. 8. Now what's the other way to get this? Does anyone see another way to get that without doing all this work? Just guess, Jeff. What's the most basic right triangle that has nice whole numbers? We just did it earlier. 3, 4, 5. Don't these reduce to 3 and 5? And they're both double those? 3, 4, 5, so 6, 8, 10. I didn't have to do any of that, yes? So in a lot of standardized tests, when you have triangle problems, so often they're Pythagorean numbers. So you can save some time by just doing that. 3, 4, 5 is a big one. 5, 12, 13 is another big one. 5 squared plus 12 squared is 13 squared. Or, you know, just do all the work. It's up to you. Okay. So then what is the perimeter of this? The shortcut is What's the perimeter? Add these and then double it. So twice 14. Is that cool? Okay. What about how far is this? 16. So we got 16. Now I got to figure out how far this is. Yes? All the way around would be what? The formula. 2 pi r. So halfway around would be 2 pi r divided by 2, which is pi r. Is that cool? Because I'm only going halfway in a circle, so I don't want to go 2 pi r, I just want to go pi r. So I've got 16 to travel this far, and now I've got to know how far to travel across here, and that's going to be pi times r, and r. They did a really poor job of this, but I'm assuming that's r. So this would be 8 pi, this distance. So then what's the total distance around? Would be 16 plus 8 pi. And then if I use 3.14, what'd you guys get? Did anyone do this one? What's up, guys? Is everybody all right?
41.1.
Yeah, 41.12. If you use 3.14 for pi, are you guys okay?
I almost had it.
Oh, okay. If you didn't get that answer, do you see why you didn't get that answer? Does anyone see?
I hadn't added the 16.
Oh, okay, yeah. That's easy to forget this dude because it's like that's easy. Your brain's like that. It doesn't matter. But I just imagine when I'm doing a perimeter, I gotta have a little dude walk all the way around the thing. Yeah. Okay. These guys, I think I talked to a decent number of you. This is all about how big the mouth is, which the first time I say that, you guys are like, what the shit are you talking about? Which is understandable. Thankfully, you don't actually just say that. How big is this angle? 67? And so it's really just a question of who's got the biggest mouth. That means I can put the biggest stick in their mouth, yes? And here I am, I'm a nerd. I think about Star Wars, I think about the Rancor, and Luke puts the stick in his mouth, yes? And you're like, whatever, dude. All right, so which one's got the biggest mouth? Which angle's got the biggest mouth? C, so the side across from it must be the biggest stick. So what's the biggest side? AB equals the largest. So what's the smallest side? AC is the smallest side. All right, I like it. Same thing with this one. Well, how big is that angle? 55 degrees. So that's automatically the biggest. Is a right angle. Is the largest, and then the smallest would be KJ. Okay, so it's all about putting sticks in mouths. Not a life lesson, kids, but okay. All right, now real quick, everybody knows the area of a triangle. Okay. You get what's the area of this one? Yeah, base times height. Yes. So here's the kind of new one. Yes. So how do I get the area of this? What shape is this? Kite. So what are the two numbers I need? A and B. So what's A? No. 12. And what's B? 12. So this will be 72. I wish they would have put units, but you know, can't have what you want. What about 18? What shape is that? It's a rhombus because all the sides are the same length, but it doesn't really matter. It's a parallelogram. They didn't give me the diagonal, so I can't do like we did here. But thankfully, a rhombus has another formula for it, which is the parallelogram formula, because it's both a parallelogram and a kite. So the area would be base times height. And what's that? 462? That sounds about right. Okay. And then finally, sorry. They tell me the circumference and they ask me for the radius. And the formula for the circumference is 2 pi r. So then I just throw in what I know. How do I solve for what I don't know? Divide by 2 pi. So then the r would be 44 divided by 2 pi, which if you put in the calculator, using 3.14, oh geez, Jeff, I get 7.01. Now if I ask you to do that kind of problem on a test or something, I would tell you how far to round. So you don't have to guess what I want. Alright. Let's call it right there. That's plenty. I got so much space. Alright. So have a really good break if I don't see you before then. Spring break! Next week, do not come to class. Next week. They won't let you on the campus, so I'll be there. Oh, if you borrowed my thick board, can I take it back?